In this video I'm looking at how to answer a question on carbonyls. So the question centres around a molecule called hydroxyethanol, and the thing to note is it contains a primary alcohol group and an aldehyde group. So I'm just going to go straight into the actual questions. So part A, the biochemist reacted hydroxyethanol with Tollens reagent. Now Tollens reagent is used to test for the aldehyde group, and when it reacts it produces a silver mirror. So that's what the biochemist would see. Tollens reagent is a mild oxidizing agent, so what it's going to do when it reacts with the aldehyde group, it's going to oxidize this and it'll get oxidized to a carboxylic acid. So you can see there's no change at the primary alcohol part of the molecule, but there is a change at the aldehyde part. So that's converted to a carboxylic acid. So part B of the question talks about reacting hydroxyethanol with another oxidizing agent, this time acidified dichromate, and it's under reflux. Now, acidified dichromate is a much more powerful oxidizing agent than Tollens, and so both ends of this molecule are now going to react. So the aldehyde part will be oxidized just as before. The primary alcohol part will also oxidize, but if you remember from your oxidation of alcohols theory, they can be oxidized twice, first of all to an aldehyde and then to a carboxylic acid. So we're actually going to get 1, 2, 3 oxidations. So you can see I've written the equation up there. So 3 moles of oxidizing agent needed because 3 oxidations take place. So we're going to end up with the primary alcohol being converted to the carboxylic acid group and also the aldehyde group. So we're going to end up with this molecule here, and there would be 1 water molecule produced. And if you remember, when you oxidize a primary alcohol, you get a water molecule produced with the first oxidation, not with the second, from the aldehyde to the carboxylic acid. So all in all, you're only going to get 1 water molecule produced. So the last part of the question, part C, talks about the opposite of oxidation now. So we're talking about reduction using aqueous NaBH4. And that's the reducing agent used to reduce carbonyl compounds. So what that's going to do is it's going to reduce the aldehyde part of the molecule. Can't reduce this part, but we can reduce the aldehyde part. And aldehydes get reduced to primary alcohols. So we're going to end up with this molecule here where we've got primary alcohol on the left, which hasn't been affected with the reducing agent, but the reduction of the aldehyde group has created a primary alcohol group on the right as well. And if you've watched my video on reduction of carbonyls, I've got this silly way of remembering it. It's the oxygen sandwich. So we need 2 reducing agents, 2 H's in square brackets, and we put 1 either side of that O. So we end up with CH2OH. So in effect the oxygen sandwich between the 2 new hydrogens. So we just need to show the mechanism now, and we're told to use curly arrows and show any relevant dipoles. So you can see I've already drawn up the hydroxyethanol, and I've put the delta plus on the carbon of the carbonyl and the delta minus on the oxygen. Obviously they are the relevant dipoles. So the reducing agent is represented as an H- ion, hydride ion, and they come from the NaBH4. And so in terms of mechanism, we need a curly arrow from the minus sign to the slightly positive carbon, and that will repel the pi electron pair completely onto that oxygen. So that would generate this intermediate here, and we've got O minus, where this electron pair has been repelled onto the oxygen, and we've got the new hydrogen here, which has obviously been, this bond here has been produced from this pair of electrons here. And then the final part of the mechanism brings into play a water molecule. If you remember, it says using aqueous NaBH4. So we've got a water molecule now, and what we need to do is draw a curly arrow from the minus sign on the O minus, and we're going to repel the electron pair in the OH bond completely onto that oxygen. So you can see I've drawn up the product here. So there's the new primary alcohol group formed there, and the water molecule would end up as an OH minus ion.